All right, so here we have two different bases, and they're in parentheses with an exponent on the outside. Does anybody remember what this rule tells us to do with those exponents? That's right. It's like distributive property. It's multiplying. 3 times the 2, 3 times the 5, which would give us x to the 6th, y to the 15. If there were a number in here, you would raise that number to that power. So you would, if there were a 2 in there, it'd be 2 cubed, which would be 8. That's what we need to do with that. So anything in parentheses with an exponent outside, you're going to multiply the exponents. All right. Let's do maybe a little bit more difficult problem. Trevor said I remember these get a little harder as we go. They don't get much harder. They get a little bit. 16 m to the 4th n to the negative 5 over 2 n to the negative 6. All right. So my way of doing this is to do all of the other rules first, and then the negative exponents rules last. Okay, that keeps me from having to move something more than once. Because remember, the rules for this are you can't leave a negative exponent in your answer. Okay, but the rules allow you to still work with them. Okay, so when we look at that, we got 16 on top and a 4 and a 2 on the bottom. So those would simplify like a normal fraction. What's 16 over 2 simplify to be? 8 over 1, right? And we'll fix this in just a second. The m to the 4th, are there any other m's as bases? No, so nothing's going to happen with him. He's just going to, or her, I'm not sure what gender the m is. But it's one of those, maybe. And then we have an n to the negative 5 and an n to the negative 6 in the bottom. So they're the same base. And this is division. So what do we do with those? Subtract them. So we have negative 5 minus negative 6. Positive 1 or negative 1? Positive 1. The answer, when you subtract, always goes to the numerator or the top of the fraction, even if it's a negative answer. So this would be n to the first power on top. We don't really need the 1 on the bottom. It works out just like that. We're going to see some that change a little bit as we go here, but you'll follow those rules first and then fix the negative exponents if they exist. Here, they didn't even exist. We didn't have a negative exponent at the end. So we want to follow these other rules first and then take care of the negative exponents. So if we had something like n to the 6th times p to the 3rd, or n squared p to the negative 5. What's the rule we're going to use? Subtraction. It's division, right? So n to the 6th over n squared. 6 minus 2 would be n to the 4th. That goes on top. And then on the p's, we have p to the 3rd and p to the negative 5. So 3 minus negative 5 would be p to the 8th. Still goes to the numerator. What's left in the denominator? Nothing, but it's a 1 in the denominator. So if that ever comes up, there's really a 1 over there. Let's look at this one. E be a to the negative 3 b squared over a to the 5th. And that's enough. Make it too complicated yet. So for this one, what's the rule for the a's? Subtract. So we got negative 3 minus 5, which would be negative 8. And the way that I do these, that always goes to the numerator. The b squared, what happens with it? Same. Nothing changes about it. So it stays up there. Technically, what's in the denominator? A 1. Technically, that's there. Now, here's where the negative exponent rules come in. We've got a negative 8. We can't leave a negative exponent. How do we change that to a positive 8? Does anybody remember? Move it to the bottom. That's exactly right. So we're going to move this a to that negative a. It's going to move to the bottom and change to a positive exponent. That's the way that rule works. So b squared stays up top. A to the positive 8 in the bottom. And you're done. Nothing left to do on that. Let's make it more fun. Let's put some parentheses in there. All right, so we got x to the negative 3, y to the third, positive 3. All that in parentheses, squared. And then on the bottom, we have an x to the 5th and a y to the 6th, both positives. So we're going to follow all the other rules first, negative exponents last. So what do we do to the top? Distribute the exponent of a 2. So that would be x to the negative 6, y to the positive 6, x to the 5th, y to the 6th. Okay? What do we do next? Subtract. Okay? So the x's would be negative 6 minus 5, which is negative 11. So we got x to the negative 11, y to the 0 power. What is anything to the 0 power? Does anybody remember? It's 1. By definition, anything to the 0 power is 1. Okay? So that y to the 0 is going to turn into just the number 1. Where does the x to the 11th need to go? On the bottom to make it positive. So we end up with a 1 on top and x to the 11th on the bottom. Anything to the 0 power is 1. A pumpkin to the 0 power is 1. A English class to the 0 power is amazingly 1. Anytime you can take an English class and put it to the 0 power, I'm all for that because I don't like English. It's hard. Math's easy. English is tough. There's too many exceptions. All right, let's get kind of regress a little bit and go to something a little bit easier on that. Or I say easier, maybe it's not. X to the negative 6 times x to the 5th times x to the 3rd. What's that going to be? X squared? How'd you get that? Add all those exponents. Even though one of them's negative, you still follow the same rule for multiplication. You add them all up. Negative 6 plus 5 would be negative 1 plus 3 is 2. So that's x squared. Nothing to fix because it's already a positive exponent. Okay. So far, pretty easy. Let's say we had y to the 5th times y to the 4th times y to the negative 12. Maybe not as easy, but still not very difficult. Well, you could. I'll get paid very much for quitting this early. Say that again. Positive 3rd, negative 3rd. Negative, why negative?
12
Yeah, 12 is bigger. So yeah, it's y to the negative 3, but we need to fix that. Yeah, 1 over y to the 3rd. Okay, so can't leave a negative exponent in our answers in section 1. Now we're doing 1 and 3. We'll just leave that one like that. All right, what's going on between these two things? They're multiplying. So what do we do with the exponents? Add them. Okay, what about that 7 that's hanging out in the front? What do we do with it? Right. There's a 1 in front of this that they don't write. So it's just like 7 times 1. So it's 7. Then what about our y's? Y to the -2, and then z to the 4th. 5 plus -1 be 4. Which one of those needs to move? Does the 7 move? Just the y. Why doesn't the 7 move? Because it's multiplying times the y. The only part that has the negative exponent is the y. That's a very, very common mistake that's very simple to fix. It's just, you got to look, what has the exponent? What is the exponent on the 7 technically? 1. If it's not written there, it's a 1. So the 7 does have an exponent. It's not the -5. The -5 is only on the y. So be very, very careful of that. I try to emphasize that. Yet I end up having to mark that wrong on a lot of quizzes in Algebra 1 for sure. Hopefully we fix that in Algebra 2 for sure. Example J, x to the 3rd, y to the 5th over w to the 4th, parentheses squared, times, let's do x to the -3, y over w to the 6th to the -2. A little bit more involved, obviously. Bigger problem, but still doable problem. Order of operations tells us to do what first? Exponents. So there's a lot of exponents in there. Which ones are we talking about? The ones on the where? The outside. That's the ones we got to take care of first. So the first fraction turns into x to the what? X to the 6th, y to the, and what about that w on the bottom? Does it get the squared too? Yes, everybody on the inside of that parentheses gets the exponents on the outside. So that's going to be w to the 8th on the bottom. Let's draw that in a different color. So let's do that. There we go. What about the second fraction? Do the same thing. We're just, what's the exponent we're multiplying by this time though? A -2. So that's going to turn it into x to the +6, y to the -2, w to the -12. Now, here's where we got to remember how to multiply fractions without a calculator, because these are all letters. You could do this in a calculator if you wanted to. So, what gets multiplied together? Does the top multiply times the bottom and bottom times the top, or is it straight across? Straight across. Okay. We could do cross canceling. I know y'all seen that with regular fractions as well. There's no cross canceling that can even happen on this one. So straight across is the way to go. So we're going to multiply straight across. X to the 6th times x to the 6th would be x to the 12th, y to the, you add it, remember we're multiplying, so we add exponents when we're multiplying. So that's where, another common mistake that happens a lot is that we're thinking multiply, 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 and forget it's exponents. We got to add exponents. So that's very, very important. I'm glad you saw that. All right, now what's the y I got? It'd be 8, +8, right? What about the bottom? Be w to the -4. Now, what needs fixing? What moves to the top? W. Do any of the things that are on top move down? No, they stay the same. So we're just going to have w to the 4th, x to the 12th, y to the 8th. I wrote in that order because OCD exists and some of us have it. It's alphabetical order, right? W, X, Y. It doesn't matter. If you put the w to the 4th on the end down there, that's fine. multiplication rules say you can rearrange it in whatever your order you want to. I just had to put it in alphabetical order, or I'd have been a little bit worried for the rest of the period. So I had to fix it. All right. Let's get another one here. A couple more for this section, and then we'll go to the fun one. So we have 2 x to the 5th, y to the 2nd, over 3 x to the negative 2, y to the positive 3, all to the negative 2 power. Whew. This is pretty difficult. Even though it's just one fraction, there's a lot going on. The good thing is you really can't screw up what order you do this in. Order of operations would tell us to do what first? Parentheses, please excuse my hearing. Parentheses comes first. So it would tell us to do the inside of the parentheses first. We don't have to do it that way though. Because it's exponent rules, we could do the exponents first and then simplify the fraction with bigger numbers in it. I'm going to do it the order of operations way because that's what it's supposed to be done. And parentheses first. So let's work on the inside first, and then we'll take care of that negative 2 at the end. So what's going on the inside? What could happen? Anybody? Subtract the x's, the exponents on the x's. That's right. So we'd have 5 minus negative 2, which would be positive 7. So parentheses, we've got the 2x to the positive 7. I know the 3 is still there on the denominator. What about the y's? We could put it on the bottom and as a positive 1. I'm going to put it up top as a negative 1. Because I know something's going to happen to it in just a second. We're going to have to rearrange stuff anyway. So I always do the rules where when I subtract, I put the answer in the numerator every time. Anytime I'm doing division, my answer goes to the numerator and I fix it afterwards. Morgan? Top minus bottom, yeah. Top minus bottom every time. That's right. Okay. All right. So we've got that part done. Now let's take care of the exponent. We did parentheses, then it's exponents. So the negative 2 exponent goes where? Who gets it? All of them. Everybody gets it, right? Kind of like the flu. Everybody gets it, it seems like, these days. So 2 to the negative 2, x to the negative 14, y to the negative 2 times negative 1 becomes positive 2. And then we got 3 to the negative 2. All right. Now, let's rearrange things where they should be. Go ahead. What do you mean?
That was, I know that can't be final answer, but say we had a final answer like that. You simplify
No. Can't divide them all by a common factor. That's what you mean there. No, you can't do that. If it's the numbers out in the front, the coefficients, you can, but exponents cannot. Good question, because that would definitely come up on this problem. What needs moving? The 3, the 2, and the x. So let's rearrange those, and then we'll finish the problem. So we got 3 squared, y to the 2nd on top, 2 squared, x to the 14th on the bottom. 3 squared is not too big of a number, and 2 squared is not too big of a number. We can go ahead and work those out, right? What's 3 squared? Yeah. 2 squared. And then this is kind of what Trevor was asking about. Could you simplify exponents 2 and the 14? Yeah, they're both even, but they're exponents, so they don't divide by 2 and make 1 and 7. The numbers in front, if this were like 8 over 4, yeah, you would divide that. But because it's 9 over 4, it won't reduce. Reduce coefficients, don't reduce exponents. Unless they're a fraction. We don't have any of those today. We'll get to those later. So there's our final answer. A lot of work for that one, but doable. Let's do uno más. Say we had 4x to the fourth, y to the negative 2, over 3, x to the third, y to the sixth, all in parentheses, and let's make it to the negative 3. Just get some more practice with negative exponents, because those are the more difficult ones to do. Okay? What do we do first? Parentheses. So we're going to simplify inside first, right? So 4 and 3 don't reduce, so I'm going to have those. What about the x's? You can end up with x to the first, positive 1, right? So that's just an x up top. What about the y's? Y to the negative 8, right? Negative 2 minus 6 would be negative 8. Then all of that is to the negative 3. Who gets the negative 3 exponent? Everybody. So 4 to the negative 3, x to the negative 3, y to the be positive 24, and then 3 to the negative 3. Move the negative, folks. So what stays on the top? Y to the 24th doesn't move. 3 cubed comes up there. 4 cubed goes to the bottom. X cubed goes to the bottom. And then simplify that. What's 3 to the third power? 3 times 3 times 3 would be 27. 4 times 4 times 4 would be 64. Do 27 and 64 have any common factors that we could divide by? Sure would be nice if they did, but they don't. We're left with that as a final answer. So exponent rules, just take a little practice and some refreshing on adding and subtracting, adding when we multiply, subtracting when we divide, multiplying when there's parentheses, and then fix the negative ones. When do we fix the negative ones? First or last? Last. That's the easiest way to do it. Technically, you can move them anytime you want to, but you're going to end up moving them 2 or 3 times if you move them at the beginning. That's why I always just wait till the end to fix negatives, because you don't have to do as many moves. The more times you move, the more likely you are to make a mistake. All right, so that's 5-1. We're going to skip 5-2 for the time being, and let's go to 5-3. 5-3 is adding, subtracting, multiply, polynomials. Been doing this for years. You just didn't call it polynomials. Here we got a couple of quadratic polynomials. How do you add those two things together? What gets put together? What are they called? Like terms. That's all the adding and subtracting is. It's just like terms. So we're adding the like term. So the like term with x squared would be plus 3x squared. So that's 4x squared. 3x plus negative 1x would be 2x. Negative 5 plus positive 7, positive 2. And you've added a couple of polynomials. Like I said, you've been doing this for years. You just didn't call it that. You just called it like terms. Same thing. They just get a little bigger. And they tend to try to throw you a curveball and put them in a different order sometimes. We're used to everything being in descending order. They're not always going to be that way. We just want to write our answers that way. So let's try to put this one together. So if we're going to write them answers in descending order, we start with the biggest one, right? Which one's the biggest one? By biggest, do I mean the coefficient or do I mean the exponent? Exponent. So the biggest exponent would be cubed, y cubed, right? So are there any like terms to the 3y cubed? No. So we're just going to copy that guy down. Or girl, I'm not sure. So I'm done with him. Or it. Trevor, put your phone up. Disrespectful. All right, now what's next? Y squared, right? So negative 2y squared and negative 4y squared would be negative 6y squared. Notice we're not changing exponents here. You're adding and subtracting, exponents don't change. It's only when you multiply do exponents or divide that exponents change. And then we got a negative 7y. It goes along with what? 2y. So negative 7 plus 2 would be negative 5y. And then I'll finish with those. All that's left is a minus 5. We've added those two polynomials. Five y squared plus 6y plus 7 minus 3y squared plus 8y minus 6. The parentheses do matter, guys. Especially, it doesn't matter on the addition, but it definitely matters on the subtraction. So, like terms again, same rule. 5y squared minus what? Which is 2y squared. Those are done. 6y minus 8y. Negative 2y. 7 minus negative 6. Plus 13. That's where that subtracting a negative, leave change opposite or leave change change. I don't know you had. Yes, sir.
Like, you had a 3y3 on the last time, you said 0 minus 3y3.
That absolutely. The next example has exactly that in it. You were reading my mind. That's exactly right, y'all. Here's what Trevor was talking about. You had 6y minus 8y squared plus 11 minus a negative 6y cubed plus 4y squared minus 8 plus 10y. So this really exactly addresses what Trevor was asking about. He was right. Because here we've got two polynomials. We want to write our answer in descending order. So which piece do we start with? Y squareds, plain-wise, y cubed. Even though it's not in the first polynomial, it's in the second one. So we have, like Trevor said, nothing y cubed minus negative 6y cubed. So what's that turn into? Positive 6y cubed. That guy's done now. Then we can start doing our like terms because now we've got matching pieces. So I go next to the squared. So negative 8 minus positive 4 would be what? Negative 12y squared. So those are done. And you don't have to mark them out when you get done with it. I just do that just because it kind of can kind of help you not look at things that you're done with. What's next? 6 minus 10, which would be what? Negative 4. So those are done. And then we have 11 minus negative 8 plus 19. All right. Adding, subtracting. Be careful of your subtraction problems, the minus and negatives and that sort of thing. And especially that little trick right there that Trevor brought up for us. That's definitely something you got to watch out for. Don't do that too much to you in Algebra 1, but they tend to make it a little bit more difficult in Algebra 2. All right, so let's go to find a product. This is still 5-3. Still the same section. The addition and subtraction we talked about. Now let's talk about multiplying. Okay. So if I'm going to multiply these two polynomials, what do I do? Can't do that yet. What method do y'all guys call this? Some of you may have a name for it. FOIL would be a name that maybe you've heard before. I don't call it FOIL method. I just call it distributive property because that's what FOIL method is. But it's distributive property with everything. So the way that I do it is I say, okay, x times both of those and get that written out. So x times 3x is 3x squared. And then I say, and then x times 5 is 5x. And then here's a little trick that I do. It's not really a trick. It's just a way of writing it that makes it easier for me to combine like terms. Is the next line, I multiply everything in this parenthesis by 4. So 4 times 3 is 12, and that's a positive 12x. And then 4 times 5 would be plus 20. And then I've got like terms stacked up in the middle. It doesn't help you so much with these short ones, but when we get to like trinomial times a trinomial, it kind of organizes it a little bit better for you. So together, that would be 3x squared plus 17x plus 20. And there we have multiplied two polynomials together. It happened to be two binomials. And so that's the FOIL method is what I use. First, outer, inner, last. That's the same format. I just call it distributed property because that's what it is. FOIL doesn't work when you have a longer problem. It only works with 4 terms or two binomials. So I guess way to say that. Let's do another binomial times binomial. Just get our feet wet on that. Again, first distribute the 2x. It's 10x squared minus 14x. And then distribute the negative 5. Be careful to distribute the sign with the number. That's a common mistake that we try to knock it out in Algebra 1, but it creeps back up in Algebra 2 because you haven't done algebra multiplying polynomials very much in geometry. You just don't do that very much in that class. So you're just rusty on some skills. So that'd be negative 25x plus 35. So that's 10x squared minus 39x plus 35. Saw this on the test Tuesday, right? You got a squared binomial. What's that mean? Yeah, it turns into a trinomial because you're doing this. Trevor's doing it in his head, but that's great. That's what I want you to be able to do because there's a shortcut to it. That you square the front, you square the back. Get x squared and 49. And then you multiply them together in the middle and double it. So that's where he's getting the 14x. And that's what it'll be to square a binomial every time. So you don't know the shortcut, write it out like that and do distributive property. It's the same answer. Okay. The shortcut's just going to speed you up, make you faster, more agile mathematician. All right, so let's look at this. Y minus 2 times negative 2y squared plus 3y minus 6. So this is where FOIL method falls apart. That there's not a FOIL method here because there's not, only 4 pieces to go with here. FOIL method, 4 letters, 4 pieces. Here we have 2 pieces times 3 pieces. So we would need a 5-letter word for that, and nobody could come up with one. So we just call it distributive property. Okay. And so distribute the y to everybody in the other parenthesis. So that's negative 2y cubed, 3y squared, minus 6y. And then distribute the negative 2 to all 3. Miss Ross calls this trick-or-treating. I think if you've had her, that's what she calls it. I always chuckle a little bit when she says it. Trick-or-treat. So negative 2y squared, or negative 2 times negative 2y squared is positive 4y squared. And then negative 6y again, and then a positive 12. So here, stacking it up, we got 2 sets of like terms stacked together. So that ends up being the final answer of negative 2y to the third, 7y squared, negative 12y, and then plus 12. And we multiply them together. Okay. Not too bad, just some good Algebra 1 skill practice today. Let's go a little deeper. A little bigger problem. We got x squared minus 4, and then a 2x to the third plus 3x squared minus 5x plus 1. This is where the stacking gets a little bit more useful when the problems get longer. And that's why I kind of do it this way. I probably didn't do this in Algebra 1. If you had me for Algebra 1, I didn't stack them like that because the problems weren't very long. But in this, they start getting longer. And if you can stack the like terms, it sure does make it quicker to total them. Or it does for my brain. My brain kind of works vertically like that with adding and subtracting because that's the way you've always done it, hopefully. So what are we distributing first? X squared. X squared goes to everybody in the second parenthesis. So that's going to be 2x to the what? X squared times that, fifth, and then the next piece, plus 3x to the fourth, minus 5x to the third, and then plus 1x squared. And then distribute a minus 4 to both all of the 4 terms in the other parentheses. So negative 4 times negative or positive 2x to the third would be negative 8x to the third. Notice I went underneath the x cubes to stack that up. So I just got to recognize like terms, and then be a minus 12x squared plus 20x minus 4. Two x to the fifth, 3x to the fourth, negative 13x cubed, negative 11x squared, 20x minus 4. A little longer, but here's what's going to happen as we go through chapter 5, Trevor. That's a good question, because what's the point in knowing all this stuff? What we're going to do the rest of chapter 5 is we're going to start with a problem like this, and we're going to break it down and go backwards to get the factors that built that problem. You could, as far as, what do you mean, like in life or in algebra class? If you were a data analyst, you could use polynomials to track trends in sales, track trends in production cost or something like that. But if you were in that field or businesses, I mean, you could use polynomials to track trends in a business that you own. Like, if you know that every June and July is your slow month, you could reduce your cost during those months by maybe letting go of your part-time workers during that time or something like that, based on the trends here that you would find using some polynomials. You could find when's the perfect time to drop them off, when's the perfect time to rehire, that sort of thing. That, to me, that's for maybe some application of it. There's not a ton of application of polynomials because there's some better things out there when you get into calculus and higher level math for doing stuff like that. But there's a few applications of it, but probably nothing, unless you're an engineer or a data analyst, you're probably not going to use them too much as far as in everyday life. Definitely not going to use them at the, on the proficient circuit, probably. I don't think so. Right, even though it's getting to be, that's a lot of numbers and things too. Be surprised how many statisticians or numbers analysts work for sporting goods companies and sports companies. Like every professional baseball team has a statistician that works for their team, and they look for trends. And part of the trends are polynomials that you can watch what's going up and down with the person's hitting and pitching and all the different things. Yeah, that's the reason I'm making you do it. No other reason, just to make you hate life. All right, let's look at letter we on. All right, let's look at a tough one. X plus 3 cubed. Eee. What happens when you cube something? It's 3 times, right? This is the obvious joke y'all don't think about. You cube something. I cubed X plus 3. Put it in a cube. That's a good one. Who? Oh, yes, you would. Mr. Christopher didn't like my drawing either, so. Do what now? I'm sorry. All right, so when you cube something, you write out 3 times. You got to multiply it out. So can you multiply all 3 of them at once? You could, but that's very, very difficult to do. And you can easily get confused. So why not just do 2 at a time? Okay, so if I break that problem apart and put those 2 together, it's like squaring X plus 3, which we know a shortcut for. This is where the benefits of knowing that shortcut are. So if I square that, that's going to be X squared plus 6X plus 9. Then, and that's coming from just multiplying X times X is X squared, 3X, another 3X is 6X, 3 times 3 is 9. Okay, that's where that's coming from. Now it's just distributing again, a binomial to a trinomial. So you can make it easier by just picking 2 of them at a time. And so that'd be X to the third, 6X squared, 9X, 3X squared, 18X, 27. And then combine like terms. Nothing really more difficult than that's going to come up, honestly. Let's go one more example and we're done for today, and you'll get the rest of the time to start working and then tomorrow to work as well. Let's take 3x squared minus 5x plus 8 times negative 7x squared plus 2x minus 9. Can't tell I'm making these up. So we have a trinomial times a trinomial. Longest problem that we're probably going to end up doing. Okay. So what do? Distribute. That's all this is distributive property. Just we have to do it 3 times because the first parenthesis has 3 pieces to it, right? So we're going to distribute the first piece to all 3 of the second piece. 3 times negative 7 is negative 21. X to the what? 4th. Yeah. Then plus, y'all help me out. All right, 6x to the 3rd minus 27x squared, right? Then I'm going to distribute the 5x. Better yet, the negative 5x to all 3. So negative 5x and negative 7x squared be negative or positive 35x to the 3rd, negative 10x squared, positive 45x. Be careful of your signs. That's the mistake that's going to get most of us. If we make a mistake, it'll probably be because we missed a negative sign somewhere or a positive sign, depending on which way you look at it. Last piece. It's distributing 8 to all 3 of those. That's the easiest one. So that'd be negative 56x squared, positive 16x, negative 72. Answers, just total it all up. Negative 21x to the 4th plus 41x cubed. 37 and 56 would be 93x squared, 61x. And we've got a polynomial built out of it. What will we do in next week with these is taking a polynomial starting like this and figuring out how do we start with that and break it down into getting the factors of it. Okay, so this is the forward direction of it. We're going to go in reverse next week. And then we're going to be able to build polynomials based on knowing what its zeros are or x-intercepts are. We're going to build out of that. And that's where the multiplying really comes into play, is building a polynomial knowing its x-intercepts. All right, so today, the rest of the day, you got about 30 minutes left. And tomorrow we're looking at page 333, 24 through 35, page 349. Look at that one. I've got even written down here, but I don't know why I did that. Maybe the even ones that I really wanted. Three. Let's do 3 through 45 odd. Be a good one to do there. A good. That's 12. And then that's 45 minus 2, or minus 1 would be 44 divided by 2 because it's odds. So 30 problems. Excuse me. Sorry. I'm giving you 2 hours to do this.
Well, that was like a lot more.
No. Sorry, I didn't mean to panic you that you would actually have to do